Let's have a look on the source code for this assignment. It's pretty simple, and here is our home directory having one Python script and two data file. So as you know already, what is wafer, and inside wafer we have a lot of die, and in this experiment we will pick some die from one wafer and we will predict the result for the other dies. Okay, let's have a look on this data file. These are same. So the first one here, we have a die position. So x, y axis of the die in a circle, and these are the values. You don't need to care about these values with the source code here. Let's have a look on the source file here. Okay, so these are the framework you have to install and import, and these are other import that you need. Maybe these are not need because we don't draw the source code, any graph. See, okay, right. So come to the point. Here is our item. We are start with the wafer 2, and you also try by yourself with the wafer 1. Here is a variable I have declared to store the result of our experiment. And this is the line where I read the wafer 2 data, right? So this is the source data. Now what I have to do, I have to take the few percent of the total data and I will predict the rest of the data using Gaussian process regression. This line is basically just to calculate the CPU time, so you don't need to consider this. And here is the loop that says that you will start from the 10% to 30%. So you have to change it until 9 to get the up to 90% to be the variable. So we have now less time. So 1 to 3 means 10% to 20% here. Okay, so here is I'm taking the sample, which is this n is a variable that we have to define the number, and the number is 10 because it's the so it's 10%, and this is a seed that I define so that every time you have the same result. Okay, so these are our train data. So within this data we are train our model. So how to find the test data? It's pretty simple. The data you have used for the train data is you need to eliminate it from the total data set, and then you will get the test data. Here is the test data. So we will drop the train data from the total data set. This is the main code of this part, a few lines of code that does everything. And here you can see that we have a kernel, and this is the model with our train data, and here we will predict the value with the test data. And this is just a few lines of code. You should try to understand for just alignment and pre-processing of the data for our result. And here is the error, and we also generate a predicted data set to see how its result looks like for our reference. And this is the calculation time for executing the code, how long it takes. This is the CPU time, so it depends upon if your computer is very fast, if the time is reduced. And then here we stored all the data, the error, and there's a number of percentage here, and finally we will store this file. So let's execute this file and check the GP error file. So here we go. I'm running the file here. It start running, and you can see that this modeling is a converse, and finally The 10% is done. Now it's working with the 20% data. As the percentage of data is increased, it takes long time for modeling. Yes, that's it. It's finished. Now let's check the result. So here we have one, two, three new files. This is the important file that contains the result. Let's have a look on this file. Yes, this is the first iteration will take the 10% and the total sample is 623 and this is the error and our status is successful. So once we increase the sample, the number of sample is also increased and the error is reduced. This way we can reduce the error. So this is the experiment that I give you, and please, after realizing and understand this code, please read the assignment document PDF file, understand your work. Thank you very much.